Hi there, welcome to my class. Today in this class we are going to discuss about TCP IP protocol suite. I'm Dr.P.Ganesh from India. So earlier class, my previous video, I have given OSI reference model in detail, and then there is a difference between similarities as well as differences between both OSI reference model and TCP IP protocol suite. So in this video, we are going to see about a TCP IP protocol suite. We are not calling as a OSI, it is a reference model. We will be calling as a TCP IP protocol suite. The main objective of this class is to discuss the TCP IP protocol suite model and its layered architecture, and to show the interfaces between the layers. As if OSI reference model, here also there are layers are there. So how it is interfaced between one layer to the another layer? What are all the specific functions of each and every layer in TCP IP protocol suite? To briefly discuss the functions of each layer in the TCP IP model, that is our second objective. With this, we will get into the topic. First, let us see that the functions of application layer. We will start from top-down approach. In this application layer, depends on what type of application you want to use. According to that, you can use your own protocols. It is similar to an OSI reference model. For example, if I'm going to use mail, so simple mail transfer protocol, SMTP. If I want to transfer files, the file transfer protocol, FTP. Similarly, based on our application, we can use our any type of application protocol into our system. Other than that, the network virtual terminal, which is going to allow the user to log on to a remote host. If you want to sitting in somewhere else, you want to access your office system, like an work from home, you can able to access it. And then a file transfer access and management. So the application allows a user to access the files in a remote host. Maybe I may be a salesperson for one MNC company. So I may be meeting some clients. In that client, sometimes we may require some data from our office. So in that case, if I have an authorized to access my files from my office, then I can go with then file access management, and through that we can able to access our files to show to our client. And then the mail services, as I said, the simple mail transfer protocol, then you can able to use any kind of mail services. This application will provide various email services. And then directory services, this application provides the distributed database sources and access for global information about the various objects and services. For example, if we are going to use some inventory control for my company, so in that cases my company may be situated in various global locations. In that cases, it has to track the inventory system. In this case, the database has to be, that inventory database has to be distributed for all these locations. So the directory services. Now this TCP IP model, which forms the base for the present day internet, whatever we are right now using in our internet, these are all follows the TCP IP protocol suite model. So the TCP and IP are the two major protocols of this model, because this TCP IP, which is going to support for both wired as well as a wireless communication. This model, which was initially used by an ARPANET. We already know that what is an ARPANET. It is an Advanced Research Project Agency network. The TCP IP protocol suite was defined as having 4 layers, whereas in OSI reference model we will have 7 layers. So here these 4 layers, we will start from the bottom up approach: the host to network, the internet layer, the transport layer, and then application layer. Now we are going to see that how the OSI, we are going to show both in a single slide, OSI reference model and then the TCP IP model, and which are all the layer functions are combined together, that as if in the OSI model. So this is a diagram of TCP IP and the OSI model. If we look at it left hand side, It starts from application. It is an OSI model: application, presentation, session, transport, network, data link, and physical. Whereas in right hand side, you can see that the application layer, where it is going to combine all the functions of application, presentation, and session layer functions in OSI reference model. There are multiple protocols: simple mail transfer protocol, SMTP, file transfer protocol, HTTP, hypertext transfer protocol, domain name system to use to identify the websites, and the simple network management protocol, and the telnet. And then the transport layer, which consists of the transport layer functions as if in the OSI model, which will have a streamed control transmission protocol, transmission control protocol, and the user datagram protocol. We know that UDP is unreliable communication protocol, TCP is a reliable communication protocol. Next, the network layer, which is similar functions of network layer, which is there in the internet layer in the TCP IP model. So here some of the protocols are Internet Control Message Protocol, ICMP, Internet Group Message Protocol, IGMP, and then Address Resolution Protocol, ARP, and Reverse Address Resolution Protocol, RARP, which is going to identify the end host systems in the particular subnetwork. And then the bottom layer, which is going to be a host to network, which was protocol defined according to that type of network which we are going to use, which is going to comprise the functions of both the physical as well as the data link layer in the OSI reference model. Now let us see each layer, how it is the functions. First, let us start with the host to network layer. It is the bottom layer of a TCP IP model, also known as the network interface layer. The purpose of this layer is to connect to the host to any network. As if in that OSI reference model, the physical layer, which is going to define the data, are going to be converted into signals, as well as the data link layer, which is going to perform both the header and adder, which is going to have a error control, flow control, identification, unique identification address inside the network. The same functions which is going to perform in host to network layer. Sometimes we may be using a wired communication, sometimes we may be using a wireless communication. That is the reason why both the layer functions are clubbed together, and we are using it in the host to network layer in our reference model. Next, internet layer. In this internet layer, the internet layer is similar to the network layer of OSI model in functionality. So just to recap that OSI reference model, network layer functions are, which is going to forward the packets. It is responsible for forwarding the packets to the source network to the destination network. It means that which is going to perform the forwarding, which is going to perform the routing of the packets from source network to the destination network, depends on the source and destination addresses. The same way, this layer is responsible for delivering IP packets to their destinations, to the destination network. An important protocol of this layer is an IP protocol. So the IP protocol, it is an unreliable and connectionless protocol. Just to recap that, we have already studied that connection-oriented protocols and connectionless protocol. If it is going to be a connection-oriented protocol, it means that the receiver device which is going to acknowledge for received packets to the sender. Whereas in case of connectionless protocol means it is not good. Receiver isn't provide any acknowledgement to the sender. So this IP protocol, internet protocol, is an unreliable connectionless protocol. Directly understood that it is not going to provide any acknowledgement to the sender nodes. So IP transports data in a packets, which is called it as datagrams. We know that the datagram approach and virtual circuit approach in a switching, which I have been explained in the fundamentals of computer network video. If you didn't watch that video, you just watch in that video. So I have given a description. In that description, I'll given all other videos link. So here in the switching mechanism, we know that packet switching mechanism, there are two methods. One is a datagram approach, another one is a virtual circuit approach. In this datagram approach, all the packets, each packets will follow a different path to reach their destination. Whereas in virtual circuit approach method, all the packets will follow the same path. So this IP protocol, we said that it is an unreliable connectionless protocol, so it means that which is going to follow the datagram approach mechanism. So IP does not keep track of the routes, which is not going to track any of the routes because each packet will follow the different paths. Now let us see how the IP datagram look like. So in this IP datagram, we know that the IP protocol, we come across that IP version 4, IP version 6, which are all most familiar IP datagrams, which is right now we are using in our internet world. So the first field is, which is going to define what is the version this IP datagram belongs to, whether it is going to be IPv4 or it may be IPv6. Next is an IP header length. What is the header length? And then differentiated services. What are all the differentiated services which is providing, which is going to be given in that bit pattern? That bit pattern is going to be 8-bit pattern. According to that, what are all the differentiated services this IP datagram, this data which is going to support? And then the total length of the IP datagram, the fourth field. And then identification, what protocol data it is, and then the different flags for identifying the protocols, and the fragment offset, and then next important field is time to live. So we know that it is going to be in a datagram approach method. Each packet will follow the different path. It is a best effort delivery mechanism. We know that IP is a best effort delivery mechanism. So the same packets may be copied in a multiple ways. So at the receiver side, there may be a duplicate copies going to receive. But on the other hand, if you look at it in the network point of view, some of the packets may be, some of the datagrams may be flooded inside the network, which will create unnecessary traffic as well as complexity in the network. To avoid that, the routing protocol itself, which is going to include the time to live, so how much time the packet has to be live in that network. After that, whichever the router which is going to identify that packet will be removed from the internet. And then what is the protocol? And the header checksum is for error control mechanism for this IP datagram. And the next two fields are source IP address and the destination IP address. And then options, if we are planning to add some more features to our IP datagram, then we can use this option field, and then padding to make it as a standard header length, and then the original data. This is how the IP datagram in the TCP IP protocol suite. Next is a transport layer. The transport layer is similar to functionality of the transport layer in OSI model. As we know that in OSI reference model, the top three layers, application, presentation and session, all these three layers it is going to be a user oriented layers. And the bottom three layers like a physical, data link and network, that layers are called as a network oriented layers. The transport layer, which is going to bridge the gap between the user oriented layers and the application oriented layers. So the same way here also, this transport layer which is going to perform the host to network and the IP, and then the application layer. So the transport layer of TCP IP model also provides the connection oriented and connectionless services. Since we all know that there are two important protocols which is going to use in an TCP transport layer, that is TCP and UDP. TCP is a transmission control protocol. It is a connection oriented. It means that reliable data communication to support a TCP protocol. Whereas in UDP protocol, User Datagram Protocol, which is going to support for the connectionless communication. Here, the main important point in UDP is how fast the packet has to be delivered, but it doesn't bother about how accurate the data is. Some of the real live streaming purposes, we can go with an UDP protocol, whereas important highly accurate data transmission, we have to go with an TCP IP protocol, which is in the transport layer. So the transport layer used TCP for reliable connection-oriented services. The various functions of TCP are error control, flow control, and sequencing. As you know that the sequencing purpose is to identify the process-to-process communication. This packet belongs to which process it is to identify that. The flow control, which is going to regulate the flow of data between one network to the another network. And then the error control to identify, detect the error as well as to correct the error with the help of header checksum mechanism. And the UDP protocol, the transport layer, use this protocol for unreliable connectionless services. There is no assurance that the packet has reached or not, and there is no sequencing number, there is no error checking also. As I said, it is going to be used for a live streaming, that kind of applications. If it's missed, that's it. It doesn't bother about how accurate the data it is. Only it is going to bother that how much fast it can able to, how quickly it can able to deliver the large data into that destination point, useful in real-time data transfer. It follows that the delivery is more important than the accurate delivery. Next, application layer. This layer is a combination of application, presentation, session of the OSI model. This layer provides various services to different user application. If I want to provide some security to that my data, then I have to go with some different encryption algorithm to that application layer itself. So what type of application we are going to use, according to that we can use some application layer protocols as we have seen in the third slide. So hope you have understood the concept of TCP IP protocol, and this we have an other than that two protocols. The other protocols are very familiar, is that several high-level protocols which can be used for a variety of applications, and the telnet is for terminal network used for a remote login, file transfer protocol, HTTP hypertext transfer protocol for fetching and web pages on the World Wide Web. Hope you understood the TCP IP protocol suite. And just to recap that entire class, in that TCP IP protocol suite, first we have discussed that what are all the different functions and what is the important functions of each and every layer in the TCP IP protocol suite. It will start from the host to network layer, and then IP layer, and then the transport layer, and then the application layer, and we have compared with an OSI reference model also. So if you have any doubts, you just write on the comment line. I'm ready to give a reply to you. Suppose if you don't watch my earlier videos, OSI reference model and the similarities and the differences between TCP IP and OSI, please watch that videos. I'll given in the video link in my description window. Please subscribe to my channel. Thanks for watching my class. Have a great day. Thank you.